Let's first look at these two illustrations. The first one says, what is the 18th term of the sequence given by an equal to n minus 3 by n plus 4? Now, how do we take this up? The sequence is given by the formula. What is an? An is the nth term of the given sequence, and how do we obtain it? By putting the value of n over here. We have to find out the 18th term. So effectively we have to find A18. Now what would A18 be? We will have to substitute n equal to 18 in the given mathematical rule for the given sequence. So n would be 18. This becomes 18 minus 3 divided by 18 plus 4. This would be 18 into 13 by 22. We obtain here 9 by 11. That makes it 117 by 11. So 18 into 18 minus 3 is, it's 15. So it will be 15 here, and we will be getting 135. So we have 135 by 11 as the 18th term of the given sequence. Now let's take up the second question. What does it say? It says, let a sequence be defined by a1 equal to 1, a2 equal to 1 and an equal to an minus 1 plus an minus 2 for all n greater than 2. We have to find an plus 1 by an for n equal to 1, 2, 3 and 4. So when n equal to 1, what do we get? a2 by a1, right? If you put n equal to 1, what do we get in the numerator? It's a2, and the denominator becomes a1. So we have to find a2 by a1. a2 by a1, a2 and a1 both are given to be 1, hence it is 1. So for n equal to 1, this is what we get. When n equal to 2, what do we get? a3 by a2. How do we obtain a3? a3 can be obtained from here. See, the given rule is this. So a3 will be a2 plus a1. When n equal to 3, n minus 1 will become 2 and n minus 2 will become 1, because 3 minus 2 is 1. And a2 and a1 we know it is given as 1 and 1. So a1 and a2 are given as 1. So a3 will become 2. So this will become 2 by 1. Hence it will be 2 for n equal to 2. Similarly, when we have to find a4 by a3, that is when n equal to 3, what do we get? a4 will be equal to a3 plus a2. a3 is 2 and a2 is 1. We get 3. So here we get 3 by 2 is equal to 1.5 for n equal to 3. Now when we take a5, it will be a4 plus a3, which is equal to 3 plus 2, that's equal to 5. So a5 by a4 will be 5 by 3, that's 1.67 for n equal to 4. This is what we get. So this is what we have to find out. We have to find out an by an plus 1 for all n equal to 1, 2, 3 and 4. So we are getting 4 values. When n equal to 1, the ratio is 1. When n equal to 2, it is 2. When n equal to 3, it is 1.5. And when n equal to 4, it is 1.67. So this particular sequence that you observe here, it's not an arithmetic progression, but it is a very special type of sequence that is very popular, and it's known as Fibonacci sequence. Fibonacci sequence goes like this. If you observe, every third term is the sum of the first two preceding terms. So 1 plus 1 will give 2, 1 plus 2 will give 3, 2 plus 3 will give 5, 3 plus 5 gives 8, 8 plus 5 gives 13, 8 plus 13 gives 21 and so on. So Fibonacci sequence is a very popular sequence you should probably go into Google and look into the details of what exactly Fibonacci sequence is and where do we find it in nature. It will be a very interesting thing to find out. Let's now get into the next set of illustrations. Now the first two illustrations that we did, we were concentrating on finding the nth term of the given sequence. Those sequences were not necessarily an AP. Now in this illustration we are going to see how we identify whether a given sequence is an arithmetic progression, and if so we will find out the common difference and the next three terms after the given last term of the given sequence. Let us take it one by one. The first example is 2, 4, 6, 8. Sorry, 2, 4, 8, 16. Here we see that the common difference or the difference between two successive terms is not constant. For example, the difference between 2 and 4 is 2. Difference between 4 and 8 is plus 4. Difference between 8 and 16 is plus 8. So we observe here that the common difference or the difference between any two consecutive terms is not a given constant. Hence, the common difference is not a constant. Thus, we can clearly say that this given sequence of numbers is not an arithmetic progression. Let us take the second one. The second one says root 2, root 8, root 18 and so on. Root 2 is root 2. Root 8 is what? It's 2 root 2. What is 18? It's 3 root 2. Now we observe what is the difference between these two terms. The difference would be root 2. What is the difference between these two terms? 3 root 2 minus 2 root 2. The difference would be root 2. So here we observe that the common difference or the difference between any two consecutive terms remains the same, and it is root 2. Hence, this is an AP with common difference root 2. How do we write the next set of three numbers? The number is root 18. The common difference is root 2. So we add root 2 to it. So root 18 is what? 3 root 2. And we add root 2 to it, it becomes 4 root 2. 4 root 2 is the next number. If we add root 2 to 4 root 2, we get the next number, and then by adding root 2 to 5 root 2, that we obtain the next number. So the given sequence is an AP with common difference root 2, and the three succeeding terms would be 4 root 2, 5 root 2 and 6 root 2. So we observe that the second one is an AP. Now we observe the third one. The third one is what? Root 3, root 6, root 9. The difference here would be root 6 minus root 3. The difference here would be 3 minus root 6. Root 9 is 3. The difference is not constant. So this again is not an AP. Now the fourth one, 1 square, 5 square, 7 square, 73 and so on. The difference between these two, 25 minus 1 is 24. What is 7 square? 7 square is 49. So 49 minus 25 is again 24. What is 73 minus 49? It is again. So we observe here that the common difference remains 24. Hence this given sequence of numbers is an AP with common difference 24. If we have to write the next three terms after 73, how do we write it? 73 plus 24, which will be equal to 97. 97 plus 24, which will be 121, and 121 plus 24, which will be equal to 145. So these are the three numbers of this given AP. So this is how we identify. For any given sequence, you simply need to take out the common difference of consecutive terms, successive terms, and if the common difference remains a constant, then that sequence will become an AP, and the difference, the common difference would be called the common difference of the AP, and if we know the common difference, if we know the term, the last term, we can always write the succeeding terms. So this is how we identify an AP and write down the terms of the given AP. Now let us take up illustration 4 and 5. Here what we do, we have been given the first term and the common difference of the AP. We have to find out the AP. We have to write down the sequence. And in illustration 5, we have been given the sequence. We have to identify the first term and the common difference. Let's see how we approach these questions. For the first one, we have A equal to 10 and D equal to 10. So the first term of an AP would always be 10. The common difference is 10. Hence the second term will be 10 plus 10, that's 20. The third term would be adding 10 to the second term. So when we add 10 to 20, we get 30. The next would be 40 and so on. So here the first term is 10 and the common difference stays as 10. For the second question, when A equal to minus 1 and D equal to half, the first term would be minus 1, the second term will be minus 1 plus half. The third term would be minus 1 plus half plus half. The next one would be minus 1 plus half plus half and so on. So what do we get? The first one will be minus 1, second would be minus half, then this would be 0, this would be half and so on. So the given, for the given first term and common difference, the progression, the arithmetic progression would be as follows: minus 1, minus half, 0, half and so on, so forth. Similarly, we can write for this. When the first term is minus 1.25, if we add minus 0.25, the second term would be plus minus 0.25 because the common difference is given as negative. It can also be negative, it can also be positive. The other cases that we have handled so far, the common difference was positive. In this case, it is negative. So we have to write it as it is given. The second term is this. So we have minus 1.25. The second term is what? Minus 1.25 minus 0.25. That will be equal to, what will we write it? We will write it as minus 1.50. The next term would be minus 1.50 minus 0.25. This would be equal to what? Minus 1.75. So the three terms that we have identified would be minus 1.25, minus 1.5, minus 1.75. If you evaluate, the next term would be minus 2, then minus 2.25 and so on. So this would be the required arithmetic progression for the third subpart. I hope you got how we reached to this. The common difference, again I would tell you that the common difference may not necessarily be a positive number, it could also be a negative number. In that case, you have to add a negative number to each succeeding term. So the AP would be going on decreasing. Now for illustration number 5, we have been given the AP. So the first term is very easy to identify. So A is 3. For common difference, since it is given that it is an AP, the common difference would always remain same throughout. So you take any two numbers and you subtract it. So the second term from the first term would be A2 minus A1. This is equal to the common difference. And here it is 1 minus 3. So we get minus 2 as the common difference. You observe here that the common difference comes out to be negative. So the terms of the AP, they go on decreasing. We start with 3, then we get to 1, then minus 1, minus 3. In this case, this is again a decreasing AP where the common difference is a negative number. So it can be possible. I mean, D can be positive or negative, anything. Now in this particular case, A would again be 1 by 3. And what would be the common difference? Common difference can be obtained by subtracting any two consecutive numbers, higher term minus the lesser term. So second term minus first term or third term minus second term, anything you can do. So we get 4 by 3 as the common difference. You take up any of these succeeding terms, the difference would always be 4 by 3, since it is given that all the given sequences are in AP. So you need not check it. Now for the third part, A would be 0.6 and what would be D? D would be 1.7 minus 0.6, that is 1.1. So the common difference is 1.1. You take 2.8 minus 1.7, you would still get 1.1. So this is how you obtain. When you have the first term and the common difference, you can write the AP, and when you have the given AP, you can identify the first term and the common difference. One important thing to note in these two examples is that the common difference can be a positive number or it can be a negative number. So this is what we understand from these two examples. Now let us see a few more examples before we proceed on to the